Let's begin this by putting a point on our piece of paper. How about right here? Well, actually, it's not a point, it's a dot. And the difference is that a point is a thing that has no size to it. It's only a location. It's a point somewhere, and it's right there. And I can't draw them because every time I do, I don't get a point, I get a dot. And dots have thicknesses and heights and widths and all that sort of thing. And points have no dimensions, only locations. We're going to label this point with a capital A. It's really a dot, but we'll call it point A. And there are just an unbelievable number of points, absolutely infinite. They can be any place, all over the place. And that's why we will say that space to us is the set of all possible points. That's what space is. Okay. Let's get another point out here, shall we? So we can talk about it some more. Let's put one over here, and since we have very little imagination, we'll call it B. And now I've got 2 points out there. I can use a compass to measure the distance between points, and I can use a straight edge to help guide my eye to draw straight things. The distance between A and B we'll use this notation for, and my algebra students will be screaming, yes, we've seen the symbols before. This is the distance between A and B to the geometry student, and interestingly enough, from A to B turns out to be exactly the same as from B to A. The distance from A to B is the same as it is from B to A. Neat. Let's take a point and say that we're going to squeeze it in between A and B someplace. Let's just say right about here. Did you notice that word, in between? We'll call that point X because we don't have any imagination whatsoever. And I can say that X is between A and B with this symbol. A, X, and B. That means that X is in between A and B. And I mean by that the distance from A to X plus the distance from X to B is equal to the distance from A to B. And that's what I mean by in between. The distance from A to X plus the distance from X to B is equal to the distance from A to B. There. And there. Well, I can't show you very well with that, can I? Let's take a straight edge, and we'll have a line that we can do some drawing on. Here we go. Right here. Let's connect these right here. There we go. The distance from A to X plus the distance from X to B equals the distance from A to B. That means that X is between A and B. If I have something up here, for example, like up there, we'll call that point Y. The distance from A to Y plus the distance from Y to B would be greater than A to B. And I can show that with my compass. If I take this and strike an arc that is equal to the distance from A to Y across here, like so, there you go. It comes down and hits right there. And then if I take the distance from Y to B, here and put it at the end of that, you can see it's way out here. It's not the same. So y is not in between a and b, according to our definition. So far, so good? Well, what we have here is a line segment AB, so we might as well talk about the symbol for line segment AB, and here it is. This means line segment AB. Line segment AB is all of the points that are in between A and B. So it would be the set of points X such that X is in between A and B. And I think I've forgotten something. We also have to include the points A and B. There we are. Line segment AB is all of the points in between A and B and A and B. And there's the symbolism for that. If I were to continue this, let's go out to the right, since I'm right-handed. We'll go left to right. And we'll just keep on going this way as far as we want to go. If I go from A through B and continue on, that's called a ray. And the symbolism for that is this. Ray AB is going to have in it all of the points that are on line segment AB. So it's going to have all points X that are a member of line segment AB joined with union all these points over here. I need something to talk about. Let's call this point W. All of the points W such that B is in between A and W. So I have the line segment and all these points over here where B is in between A and W. And that makes my ray A through B, like so. If I continue on to the left, this way, as far as I care to go, and we'll call these points over here Z. Then I'll have the whole line, AB, and the symbol would be just as you would expect. Line AB is equal to the points Z such that Z has A in between it and B such that A is between Z and B. That would be all these over here. And now we would have to get these in here, so we'll join to that. We'll union all the points X such that X is between A and B. And we'll get these over here. All the points W such that B is in between A and W. Did I forget anything? I sure did. We have to also include A and B. A, comma, B. Please excuse my poor handwriting. There you go. That's what a line is. It's a set of points that satisfy the requirements that we've set up for the betweenness, and there's how it's written. Let's get another sheet of paper, shall we? Here we go. And for discussion, here we'll go. Let's take and put another point here. We'll just call it A. And another one over here, and we'll call it B. And we'll pick a point somewhere in between and call it X. Between any two distinct points, I can find another distinct point. that is in between them, which means there's another one in between A and X. So how about this one? We'll call it Y. And between A and Y, there would be another one. Let's call it W. And since these things have no size, I could keep this thing up forever. Between any two distinct points, I'll find another point. And as you can see, the points get extremely close together to a point where I won't be able to draw it anymore. But if it goes on forever, and the points are of infinitely small size, then this could just go on as far as one can imagine. Points are really small things, aren't they? Okay, let's take and get a construction line here. Use my trusty straight edge, and we'll just sketch a line we can work on. Let's pick a point on it here. And we'll take our trusty compass, which we use to measure distances, and pick something we think is convenient, say about like that. And we'll swing this distance across here and find a spot which is that distance away from my first point, and we'll label this another point. And we'll do it again. And we'll do it again. And we can keep this up as long as we have the patience for it. It goes on and on and on, and it goes in both directions. This way also, and this way here, and so on. Okay? My first spot was here. Let's call that 0, and this one 1, 2, and 3, and we've got the beginnings of the number line, -1 and -2, and so forth, as far as I care to go. And these, of course, are the integers, and these would be the coordinates of these points. I can name these points if I wish with letters. I can say this one here would be A, and this one down here could be B, and so forth. And the names of the the names of the points would be the capital letters, and the coordinates of the points would be the number and the number line underneath them. And that's very useful to our trusty little algebra students. They like this stuff. Okay, so far so good, huh? Let's get another sheet of paper. There we go. Let's pick a point up here this time. And another one down here. Well, let's see. It doesn't much matter. We'll just call this one A and this one B. Now, I don't know where it is exactly, but I'm just going to guess. Somewhere in between A and B, there's going to be a point such that the distance from this point to A is the same as it is from that point to B. And I'm going to call that my midpoint, M. So, if the distance from A to M is equal to the distance from M to B, and M is in between A and B, then that's what I mean by a midpoint. That's my definition for midpoint. Pretty neat, huh? I'm going to continue this drawing, and we're going to play with it a little bit. Let's take this here, and above this, for my midpoint, let's make this a nice solid line. I should say a ray, going up like so. And below my midpoint, I'm going to make it a dotted line, like so. There we are, something like that. So far, so good? Not bad. Now, what I want you to imagine is this. I'm going to take and try to sketch a sheet of paper. Now, I'm not very artistic. I'll just do the best I can. My sheet of paper is going to be rectangular. Or no, it's not either. It's just going to be a four-sided figure. How's that? Not even rectangular. It's going to be a four-sided figure. Something like this. And my sheet of paper intersects my line AB, at midpoint M. Okay? And then down here, this way, like so. And this would be below the sheet of paper, and that would be above the sheet of paper. And when it peeks out behind the bottom of the paper, then you can see it down here. So this should help your imagination a little bit. This right here is hidden underneath the sheet of paper. This is above the sheet of paper, and that's below the sheet of paper. And the distance from here between A and M is the same as it is between B and M. And these little hash marks indicates that the segments are the same length. If this sheet of paper intersects this exactly right, then I can find another point on the sheet of paper out here, and if you were to measure from here to here, and from here to here, since this sheet of paper goes back further away from the line, and this is in front of that point, these two distances are equal. You're going to have to use your imagination now. Let's pick another spot, say it's over here somewhere. The distance from here to here is going to be the same as the distance from here to here. And I can keep this up as long as I wish. Come down here. The distance between these two, here, out into three-dimensional space now, which I can't actually have, but I can make a drawing that sort of represents it. Then this one here would be the same as this one here. This sheet of paper is infinite in size, and all of these are such that for any point that I have picked here, let's say, for example, point X out here, any point that I have picked out here, the distance from A to X is going to equal the distance from B to X for any of those points. And this goes on forever in all possible directions. And this then is what we call a plane. So that's plane P. If I have sets of points X such that the distance from A to X is equal to B to X, for all points that I get, I will find that this is a plane. Plane P. Plane P. Okay? That's what a plane is. Wow, how about that? We're going to be working on the plane. We will not do anything in three-dimensional space other than describe what a plane is. Well, I will show you one thing that is not on the plane in just a second. Let's get another sheet of paper. Pick a point. And on my sheet of paper, on this point, we're going to pick up our trusty compass, and we're going to swing all the way around and see what we get. This is just a simple little drawing, nothing to it. There we come. Oops, there. Try again. See, you're going to have to deal with human error here, and believe me, I make a lot of mistakes. Here we come, all the way around, like so. All right, you have to use your imagination now. It's obviously a circle. The center of the circle I'll call point O. And if I pick a point over here that is on the circumference of the circle and call that one X, then the line segment OX would give us a radius. Ta-da! Radius. If I were to continue the radius straight through the center and come out the other side to here, and call that one Y, then line segment XY, or YX, would then be a diameter There we go. And now that's laying nice and flat on the plane of my circle, on the plane of my paper, excuse me. If I were to draw another diameter through here, for example, like so, and use that to guide my eye, and now I'm going to come out into space. This one here comes out off the paper, and this one here goes around behind the paper, like so. Okay? And I'm going to do it here also. This one here comes off the paper, and this one here goes around behind, like so. And what we have there is a representation of a sphere, which is then a three-dimensional object. And anywhere that you'd like to draw from the center to the edge of the sphere, say here, would be a radius of the sphere, and it would be the same in all directions. So that would be a three-dimensional object, and that's the last one we're going to see. The circle is a set of points on a plane that is equal distance from its center, and a sphere is a set of points in 3 dimensions that is equal distance from its center. So the only difference is that the circle must stay on the plane. And that, my friends, is our introduction to points and our start of our discussion. And we hope you stay with us for the rest of these things. Talk to you later. Bye-bye.